Hi all. Today we are going to discuss about methods for handling deadlocks. Already in the last video I discussed there are mainly four methods for handling deadlocks. That is, first two methods are we have to ensure that the system will never enter a deadlock state. Okay, that two methods are deadlock prevention and deadlock avoidance. And third method is allow the system to enter a deadlock. System is going to entering a deadlock state and then recovering from it. And fourth one is ignoring that problem itself, because in early once it will be going to affect in those cases, just ignoring that problem and move on. So these are four methods for handling deadlocks. So here in this video, we are going to discuss how we can handle deadlocks by using deadlock prevention method and deadlock avoidance. Okay. So first is deadlock prevention. How you can uh, avoid or prevent deadlock by the first method. Okay. So usually in this method, deadlock can be eliminated by preventing at least one of the four required conditions. So already we discussed what are the main four conditions for occurring a deadlock. Correct? We have discussed that is mutual exclusion, hold and wait, no preemption, and circular wait. These are the four required conditions we have already discussed to occur a deadlock condition, right? These four conditions, that is these four situations, has to mandatory occur parallelly or all together, then only that deadlock situation is going to happen, right? So how you can prevent this deadlock? First method is any one of this among these four required conditions, any one is not satisfying, then you can actually eliminate or prevent the deadlock. Okay, so how you can control or how you can prevent at least any one of this condition that we are going to discuss. So first condition for occurring deadlock is mutual exclusion. So what was mutual exclusion? We have discussed that is one by one, that is each process it is going to allocate a resource, means that resource is not at all shareable with any other process till that process is going to leave that particular resource from its execution, then only that resource will be actually going to allocate some another resource. That is one to one. If a process is going to use that resource, means only that process can use its resource. So that is, it is not at all shareable. Okay, so if how we can prevent actually deadlock, that condition is how you can remove that mutual exclusion thing. That is how we can possibly we can share the resources among all the processes. Actually, you can see that all the resources are impossible to share. Okay, example like printer. So you are having only one printer, means it is impossible to share with other resources. There will be having some another options and all, nowadays it is there, but we are not going into that. But now, as of now, actually, if you are having a printer, means it will be going to share only to one process. It has to complete that process, then only it will be going to allocate to another process. So not all the resources are in the shareable mode. So this first case, that is removing the mutual exclusion, is all practically it is not possible. That is sharing the resources among the process of, or sharing all the resources among the process are actually practically not possible. Okay, that is first thing. Next, second condition how you can prevent deadlock is preventing hold and wait. That is, if your hold and wait conditions happening, means deadlock will be going to occur. So you have to remove that condition, remove that situation like hold and wait. What was hold and wait condition? Hold and wait means the process will be going to hold a resource, at the same time process is going to request another resource, right? So that situation we have to remove. Okay, so it must guarantee that whenever a process requests for a resource, it does not hold any other resource. That is how we can prevent this particular situation. Okay, for that you can actually we can do mainly three things how we can remove actually hold and wait situation. First situation is how, first thing how we can remove this situation is we have to require, see, before process is going to start its execution, whichever the resources it need for its completion, it will be going to request. Okay, that is, it is going to allocate, it is going to access all the resources whichever the process need, and then it will be going to start its execution. That is first stage. That is requires process to request. Here it is require process to request and be allocated all its resources before it begins execution. Before beginning execution of any process, it is going to allocate whichever the resources it need. If suppose some resources is not free, then that process is not going to start itself. It is going to wait for all the resources to allocate, then only it will be going to begin its execution. That is the first condition. But you know that we are having very less resources will be having in the system. Okay, so waiting for all the resources, sometimes it will be practically again very difficult to implement. Okay, so this also actually practically it's very difficult to implementation is not possible, or implementation is very difficult. And another method is allow the process to request resources. Requesting resources, it has to check whether that particular process has none allocated to it. When the process has none allocated to it, it will be going to request resources. Okay, it will be going to only requesting the resources whichever the resources is not allocated to any process. That also it is practically not possible, because sometimes we need some processes resources whichever that time that resource will be going to use by other process. Okay, so practically this condition or this thing, it is implementation is not possible. Okay, so next method under hold and wait, to remove hold and waiters, we can set some time quantum for resources also. Okay, so it is like suppose one process P1 has allocated with a resource R1. Okay, and we can set a time quantum for that particular resource R1. So it is like 5 minutes means 5 minutes only will be going to allocate that resource for that process P1. Once after 5 minutes, that resource will be going to it has to exit, it has to deallocate from the process. So that is actually another method you can use for removing hold and wait. That is wait timeout. That is time quantum is setting for each resource. It is like time sharing operating systems. That is, after fixed time, automatically that resource will be going to deallocate from the process, and it will be going to adding in that available list of resources. Okay, so this actually method is practically possible. This first method is actually not possible. This wait timeout method is practically possible. Okay, so in hold and wait, what is the two methods? That is, first thing is, before going to start its execution of any process is first allocating all its resources first, then it will be going to start. Okay, so if any resources is not, it has not get means, this process has to wait for so long time to get its resource, then only it will be going to start its execution. So that is actually practical implementation is practically very difficult, or it is not at all possible. Okay, so another method practically possible is wait timeout. That is, we are setting some time for each resources. So once a process P1 is allocated to a resource R1, or a printer means that particular printer we are setting a time quantum 5 minutes means that process can use only that printer for only 5 minutes. After that 5 minutes, it will be going to deallocate from the process P1, and it will be going to insert in the allocated which another some process that is waiting for that resource, it will be going to allocate. So that is how you can remove hold and wait condition. So that is first two conditions, mutual exclusion and hold and wait. Next is no preemption. So no preemption means what? What was the condition? No preemption. No preemption we have to remove. That means what? Preemption we have to insert, right? No preemption means what? In between any execution of any process, we can't forcefully remove that resource or a resource from that particular process. That was no preemption. So including avoiding no preemption means you are inserting the preemption concept, right? So what is the first point is, if a process that is holding some resource request, okay, suppose if a process is already holding some resource request, another resource that cannot be immediately allocating to it, then all the resource currently being held are released. That means what? That particular process is holding some resource. Currently that process has allocated, suppose process P1 has allocated, already it has allocated with resource R1 printer. So for process P1 already printer is allocated, that time only immediately it is going to send a request for the CPU time. Okay, another resource R2, it is going to send a request for CPU time. Okay, then what is going to happen is immediately that particular process won't get the CPU time because it has sent a request. Immediately CPU is not available and it has to wait for that particular CPU timers. Whatever the process resource that is having by that process, it has to release that resource also. That is, currently that process is having printer and it has requested for CPU. CPU is not available at this time. So what it has to do, anyway it has to wait for CPU time, right? And already it is having printer in his hand. So what he is going, anyway he has to wait. So that particular time this process has to release the printer in his hand also. So he is not actually holding anything because he is going to wait for some resource. So he is going to release whatever the resource he is having in his hand. That is, he is not holding anything because he is waiting for something, right? So that is this point. That is, so once it is, that is, it is holding some resource. That holding some resource, it will be going to release. If it has to, it will be going to, holding resource will be going to release if it has to wait for some another resource. Okay, so this particular no preemption is possible only for waiting process. Okay, you can do this particular releasing option only for waiting processes, not for running processes. Okay, that you have to keep in mind, that some process it has to wait for some other resource, then it has to release whatever the process it is already having in his hand. Okay, so once preempted resources are added, so once it is released, those preempted resources will be going to add to the list of resources, for which from there another process can be used by this printer. So in this example, so printer, he is going to release it, it is going to insert in the available list of resources so that other process can use this printer, right? So and once that another process P1, okay, when he has to restart, when it is restart his execution when it is gaining the CPU time. So whenever he is going to gain the CPU time, that time again it has to restart by acquiring the printer and the CPU time. It has to ask or it has to execute once again. Okay. So in concluding, waiting process, whichever the process it is going to wait for some another resource, it has to preempt or it has to release whatever the resources currently has allocated to it. Okay, not for any running process. Okay, so that is third condition, no preemption. Then fourth condition for creating any deadlock was, we have discussed, as circular wait. So any circular wait is happening means there will be happening a situation called deadlock, right? So we have to remove that particular circular wait. Then you can avoid you can prevent the deadlock situation. So how you can avoid or how we can remove the circular wait by using the two protocols. Okay, so first protocol is, so suppose here in this example, we have already discussed this example. This example you can see that there is a circular wait. That is, process 1 has allocated a resource 1, it is waiting for the resource 2, it is already allocated to process 2, again process 2 is waiting